Hello everyone, this is the first lesson recording for IM2, March 10th, 2021. We started by doing a warm-up exercise, application problem. So please read this and see if you can solve it yourself. Gabby is creating a decorative rock garden that will cover 12 square feet of her backyard, including its frame. She plans to build a 6-inch wide wood frame around the rock garden to keep the rocks in place. If the framed rock garden is square, how much area will Gabby need to cover with decorative rocks? Draw a diagram, label what you want to find as x, and write an equation to represent the scenario. Then solve the equation. Okay, so the first thing I would like you to do is find the side length of the rock garden. If you find that, you can tell me in private chat, and then eventually find the area of the rock garden. Please pause the video and try to do it yourself. Here we go. Okay, this is a picture of a rock garden. So I am going to call one side length x foot, the other side length x foot. I am told that the frame is going to be 6 inches wide and it's going to be covering all 4 sides. So what is the total length? Total length is going to be, to figure out the total length, you're going to have to add 6 inches on both sides. So that means you have x plus 6 inches plus another 6 inches. 6 inches plus 6 inches is 12 inches, and 12 inches is same as 1 foot. So I'm going to convert that into foot, x plus 1 foot, because the area is measured in foot squared. So the total area, including the frame and the rock garden, will be x plus 1 is one length, and the other length is x plus 1. So x plus 1 times x plus 1. And we're told that the total area is going to be 12 foot square. That is the reason I converted this to foot, because I knew that the area was going to be in foot square. So then x plus 1 times x plus 1 is same as x plus 1 all square. And on the left hand side you just have the square term, and on the right hand side is a constant. That means the easiest method to solve this is by taking square root on both sides. Remember, when you do that, you need to make sure you put in plus or minus on the side with the constant. So on the left hand side, square root and square cancels out and leaves us with x plus is equal to plus or minus. What is square root of 12? 12 can be broken up as 4 times 3, and square root of 4 is 2 times 3. So square root of 12 is same as 2 root 3. From here, I am going to break this up into two separate equations. So x plus 1 is equal to the positive version, and x plus 1 is equal to the negative version of 2 root 3. Then bring x to the other side. So x is negative 1 plus 2 root 3. The other solution is x is negative 1 minus 2 root 3. And if I use my calculator, this is going to give me the measure of, this is going to be about 2.46. This is going to be negative 4.46 because, yeah, they are both negative. Okay, now with application problems, when you found your solution, you need to interpret it as well, right? Can the length x is the side length of the rock garden? Can you ever have a length that is negative? No, you cannot. So we discard this as the valid solution. That means x is approximately 2.46 is the only solution that we can have for the length of the rock garden, or negative 1 plus 2 root 3, which is the exact value, or the approximate value is about 2.46. Now the question actually asks you to find the area of Gabby's rock garden. Okay, we don't want just the length, we want the area. How do I find the area of a square? It's going to be one length times the other length. Whatever the x we found the x to be approximately 2.46. So the area is going to be x times x, which is 2.46 times 2.46, which is approximately 6.1 foot square. So we started off with 12 foot square, but out of that, after putting in the frame, you're left with 6.1 foot square of area for the rock garden. Okay, if you want to do more exact calculation, you can have a look at this for those of you who are planning on going to IM3 STEM. You might find this interesting. Okay, so what have we talked about last week? We've talked about imaginary numbers. So, but previously, the week before, we've talked about number classification, and we said all of these numbers plus irrational numbers. Okay, so these are rational numbers that include integers, whole numbers, and natural numbers, plus irrational numbers. We call all of those real numbers. Real numbers are the numbers that you can put on a number line. Okay, just on the horizontal number line. What are the numbers? Pi, square root of 2, square root of 7. They can all be on the number line. Then we introduce imaginary numbers. The numbers that contain I, the imaginary number I. Okay, so as soon as we've introduced imaginary numbers, when we combine the real number with imaginary number, so we call that complex number, because complex number always has the real part. Remember, that's 4 is a real part and the imaginary part is 3i. 5 is a real part, negative 2i is the imaginary part. Okay, so that's complex number. So this complex numbers is the most complete classification of all numbers. So all numbers fall in complex numbers, and within that there are real numbers and then there are imaginary numbers. So why do we care about complex numbers? Well, TLDR version, okay, or the condensed version, is that it helps us solve more quadratic equations, but beyond that, you're going to come across a whole lot more in physics. Okay, when you talk about waves, anything that oscillates, like electricity or even sound or electromagnetic field, many of those things involve imaginary numbers, and it can be solved using imaginary numbers. And you can even see how you can create a fractal using complex numbers and so on. These are all more advanced stuff that hopefully you'll get to do. Pretty cool stuff. Look forward to it. Alright, so then we use complex numbers to solve quadratics. So if you have x squared plus 16 is equal to 0, how do we do that? We first set x squared is equal to negative 16, and previously we've said there were no real solution, but now because we know complex numbers, we can say they have two complex solutions. This is from last class slides, so do not need to write it down. Also, the next slide, we can also use quadratic formula where we're going to come across complex numbers. So if you are trying to solve this quadratic equation using the quadratic formula, first you need to convert this into standard form that is equal to 0. So we do that and identify what is A, what is B, what is C, and then you substitute. Okay, and then finally my two answers are 5 plus 2i root 3 or 5 minus 2i root 3. This is all from last lesson, so you do not need to write this down. Okay, so looking at this, I would like you to work on complex number solutions, card number 1 to 4. I want you to get a little bit more practice in solving using complex numbers. So please pause the video and work on card number 1 to 4 of Desmos. Okay, here we go with the Desmos. Card number 1, 3x squared plus 75 is equal to 15. The first thing you should think about is, what is the best method to solve this? Well, I only have the x squared term and constant. That means the best way to solve is by doing square rooting. So I need to bring the 75 to the other side by subtracting 75. So that becomes 3 3x squared and subtract 75 from both sides. That leaves us with e is equal to 60. Okay, and then from here I need to divide both sides by 3 so that I am left with just x squared. So that cancels out and you're left with x squared is equal to 60 divided by 3 is just 20. And then from here I want to take square root of both sides. And when I do that, don't forget my plus or minus sign. The square root and square cancels out on the left hand side, so you're left with x is equal to plus or minus square root of 20. I can simplify the square root of 20 by breaking up as square root of 4 and square root of 5, because 4 times 5 is 20 and 4 is a perfect square. This becomes plus or minus square root of 4 is just 2 root 5. Okay, that means that x is, oh, I made a big mistake, haven't I? What's my mistake? And this is a common mistake. I lost my negative sign. Okay, so that was supposed to be negative 20. That means I need a negative 1 here as well. So that becomes 2 root 5i. So that means it's going to be positive 2 root 5i. Or the other solution is x is negative 2 root 5i. And the answer is the solutions are complex because it involves I. And whenever it involves I, it's going to be complex. So I'm going to say it's complex. Card number 2. X squared is over 3. X squared over 3 is equal to negative 30. Okay, how do I solve this? Okay, x squared divided by 3. I don't want x squared divided by 3. I want x squared just on the left hand side. So how do I do that? How do I get rid of this divide by 3? I multiply both sides by 3. And that cancels out and you are left with x squared is equal to negative 90. That means that I can take a square root of both sides. Don't forget my plus and minus sign. That leaves us with x is equal to plus or minus square root of negative 90 can be broken up as square root of 9 times square root of 10 times square root of negative 1. Because I'm choosing 9 because 9 is a perfect square. That becomes plus or minus square root of 9 is 3 root 10 I. Do not put the I inside the square root sign, please. Okay, you can put the I in between 3 and square root of 10, or you can put it at the end. Either will be fine. So that means x is equal to positive version, which is 3 root 10 of I, or x is equal to negative 3 root 10 I. And so because the solutions involve I, the imaginary number, the solutions are complex. Number 3, solve using quadratic formula. Okay, the first thing we need to do when you have a quadratic equation is to turn it into standard form before we can use quadratic formula. So I need to bring 5x to the other side by subtracting 5x. So that becomes 2x minus 5x is negative 3x plus 5 is going to be equal to 0. Okay, now from here I need to figure out what is a. A is the number in front of the x squared, which is 4. B is the number in front of x. It's not 3, it's negative 3. And C is 5. So then x is negative b, which is negative of negative 3, plus or minus square root of b squared, negative 3 squared, minus 4 times
A